we're going to start section 4.4. Nope, I'm sorry, that's 4.5. So today we're going to talk about graphs of tangent, cotangent, secant, and cosecant functions. Rather than going through and kind of deriving what the parent function is going to look like and dealing with all that, it's essentially the same process. It just, the values are going to change, so we're going to kind of cut to the chase here. If you were looking at your key points sheet, if I can find it. Actually, let's just drop it in here. So if you're looking at your key point sheet, you'll notice that we have key points for tangent, cotangent, cosecant, and secant, all in here already. So let's just take a minute and do some examples of graphing a couple of these to kind of get a feel for what the shape looks like, but the process is exactly the same. The only difference is you're going to have these key points that are different. Everybody okay with that plan? Okay. So let's say that, for example, we're asked to do, we're asked to graph let's say that we were asked to graph y equals -2 times tangent of 2x plus pi minus 3. So the first thing I want to do is, good, but before I can find that, what I need to worry about is this. Notice here, is this written in our kind of standard form? No, what should I need to do first? Yeah, I want to factor that 2 out front, right? Everybody on board to there? Okay. And if I really wanted to be super duper technical and write this in standard form, this coefficient should be 1 over b, so I should write it as 1 over 1/2, right? That's the same thing as 2. And this should be a subtraction symbol, so I can write that as minus a negative, like that. Is everybody okay so far? Oh, good. All right, let's identify what our A, B, H, and K are. Wouldn't what? So I need 2 to equal 1 over b, right? So if I cross multiply, I get that 2b is equal to 1. And if I divide both sides by 2, I get b is 1/2. So that's the same thing as writing 1 over b. When we do the map, yes. But we're not to that point yet. When we write the map, yes. Yes. So you're just a step ahead, I think, Julia. So the A value is 2. The B value is? The H value is? And the K value is? Everybody happy there? Okay. So the map that I'll write is going to be 1/2 x plus, well, I'm going to write it as minus, I suppose, because it's plus a negative. Yes. So that is an important thing to catch, is you got to make sure that you catch that h value is always the opposite of the sign that it looks. So there's my map. And now I'm just going to copy the key points for tangent, which we can see over here. So the ones in white are the only ones that I need. I don't need the ones in gray. Those are just giving you 2 pi's worth of points. But you might notice up here it tells us that the period for tangent and cotangent is pi rather than 1 over pi. Or I'm sorry, rather than 2 pi. So that's why you really don't need all of that. So we're just going to take just the white points. So I'm just copying down now the key points for the tangent function. Notice that I have the letters U and D there. What do you suppose those stand for? Yeah, it does. And you guys have already evaluated tangent and seen that sometimes tangent is undefined, right? When is tangent undefined? The same time that cosine is equal to 0. So you notice cosine is equal to 0 here at pi over 2 and 3 pi over 2. So you notice here pi over 2 and 3 pi over 2 and negative pi over 2 are the same place on the unit circle. Right? So that's why those are undefined. Because again, tangent is sine over cosine, right? It's undefined. Exactly. Yes. Okay. So now we're going to go ahead and plug these things in and evaluate. So when I do the x's, I have negative pi over 4 minus pi over 2. But to do that, what am I going to need to have? Common denominator. So I have pi over 4 and pi over 2. What's the common denominator going to be between them? 4. So I'm going to write pi over 2 as 2 pi over 4. Everybody okay so far? Just making common denominators, right? Like adding fractions back to middle school. Should feel fairly familiar. Now, what is negative 2 times undefined? Nope. Undefined still. And what's undefined minus 3? Still undefined. Doesn't matter what you do to it. Undefined is still going to remain undefined. Because if you take something that has no value and you multiply it or divide it or whatever, doesn't matter, it's still going to give you undefined, right? Everybody's okay with that? So if it started undefined, it's going to end undefined. There's nothing we can do in our mapping that's going to change that. Now I just need to combine like terms in my fraction. So I have that. So far, so good? So has anything really changed? Just the key points that I'm using, right? Everything else has been identical. Well, I guess we have this undefined thing that comes up, but that's not difficult to deal with, right? Well, I multiplied the numerators together and then the denominators together. Yep. No problem. So now we'll do the same thing. So I'm going to have 1/2 times negative pi over 4 minus pi over 2, comma, negative 2 times negative 1 minus 3. So when I do 1/2 times negative pi over 4, I get negative pi over 8, right? And then I still have the minus pi over 2. And then negative 2 times negative 1 is 2. And I still have that minus 3. Now to add these together, what do I need to have? What will that common denominator be? It will be 8. So I'll multiply this second fraction by 4 over 4. So I'll really have 4 pi over 8. On to my next one. And thank goodness, here's an easy one. Everybody okay there? Much easier. Now we'll do the next point. Everybody still doing okay? So the next point turns into negative 3 pi over 8, comma, negative 5 at the end. Everybody, we're still doing all right? So far, so good? Feels very familiar, right? Just like what we got done doing. So the only difference is going to be the key points and dealing with those undefined parts. Just making a common denominator there. Nobody get freaked out. Please, I mean, like, I guess if you get freaked out, you get freaked out. But try not to be freaked out, because that's all I did. Well, you still need the x-coordinate. But yes, you can just take the y-coordinate straight to undefined. Yep, because that'll always be the case. Okay, so let's get ready to graph this. Now, if I'm going to graph this, how should I make my x-coordinates? What should I be going up by? I would go up by 8ths of a pi, because I can rewrite this thing as like negative pi, or 6 pi over 8. This one is negative 4 pi over 8, and this one as negative 2 pi over 8. So it looks like I'm just going up by 1/8 of a pi on the x-axis each time. Is everybody all right with that? Does that make sense on how I came up with that as a natural unit for my x-axis? Tommy, will you grab the light for me? I think it's kind of getting, it's awful bright in here to see some of this stuff with all the different colors I'm using. It's like a Skittles ad up here. You taste the rainbow. Don't lick the projector though, please. That'd be really gross. You were thinking about it, weren't you? Yeah, I saw you. Maybe. Okay. Oops. Let's put that more. So I noticed that all my x coordinates are negative, so I'm going to start in that direction. And I'm going to try to graph 2 pi's worth of stuff. So I'm going to go ahead and graph out to 2 pi, and I'll just kind of keep repeating the pattern until I filled up 2 pi's worth. And then my y coordinates are all negatives. Okay. Everybody ready to start this party? Yeah, I'm ready to get this party started. Okay, so the first thing we're going to graph is at negative 6 pi over 8, and we're graphing undefined. So I'm going to count 6 tick marks over. 1, 2, 3, 4, 5, 6. And the way you graph undefined is you just graph like a dotted line vertical. Then I'm going to do negative 5 pi over 8, negative 1. So I'm just going to count 5 over and go down 1. And then I'm going to do negative 4 pi over 8, negative 3. So I'm going to count 4 to the left and then down 3. And then I'm going to do 3 pi, negative 3 pi over 8. So I'm going to count 3 over and go down 5, and then I have negative 2 pi over 8, and that's undefined again, so we'll have another one of these. Everybody okay there? So to connect them, my general shape for the graph of a tangent is kind of like this. So notice that my graph doesn't cross these dotted lines. These dotted lines are examples of something called a vertical asymptote. Hopefully you remember from your algebra class last year when we talked about rational functions, we also talked about vertical asymptotes. Okay, so now it's time to just kind of repeat until I filled up 2 pi's worth of stuff, right? Okay, so the next one is here, and that's, is at negative 1, and the next one here at negative 3, and then the next one at negative 5, and then I have another asymptote. And then I'm here again at negative 1, and then negative 3, and then -5, and then my asymptote. And then, yes, sir? Julia? Yeah. 1 second, I just want to draw this line. No, they're happening in the same order that we're seeing here. Okay, so here the first one happened at -6 pi over 8, and then undefined. So I counted from 0 over 6 tick marks, and then I put my vertical line, and I went to the next one, which is 5 pi over 8, so I counted. Exactly. Yes, the undefines are where the asymptotes are. They're the same thing. When I have an undefined as my y-coordinate, what I'm getting is a vertical asymptote there. At least in trigonometry. Everybody okay with that? So again, I'm just going to kind of keep repeating. And there's me up through 2 pi, so that is going to be good enough. Exhausting to cram all those stupid things in there. But notice I only had to generate 5 points, but I could do as much graphing as I really wanted. You know what I'm saying, guys? So that's not too bad. The graph of cotangent is going to look similar to this, so you're going to have lots of these vertical asymptotes and these little, like these things, as your graphs. I think for cotangent, though, they actually go the other way. But the points would tell you how to do that. Let's do another example now. Let's do a secant or cosecant one. Yes, Gabrielle? So you're only going to worry about the white ones here for tangent, cotangent. The gray ones are just so you have 2 pi's worth of points. But since the period for tangent and cotangent is only pi, you really only need the white ones. But I included like 2 pi's worth of points just so everything is consistent. So let's do a cotangent or secant or cosecant one. Notice here that we have a lot more key points, unfortunately, for these cosecant and secant ones. So they're take a little bit longer. There's a little bit more writing, but that's okay. It's still doing the exact same thing. You just have more kind of points to grind through. So let's just write out an example. So let's say y equals, somebody give me a number they like. 3. And then what do you think, secant or cosecant? All right. And then somebody give me another number they like. That's too big. 1 sounds good to me. And then let's make this crummy and pick pi over 3. And then give me another number you like. What? 9? Ugh, okay. That's borderline too big, but because it was an H or a K, I was okay using it. If you had tried to give me that for the A or the B, I would have rejected that as too big. Okay. So, let's start by rewriting this so that it's kind of in that standard form. So there's not much to do here in that regard, right? So it should be easy to see our values for A, B, H, and K. A is 3. B is, H is pi over 3. And K is -9. Just for grins. Okay. So now let's write our map. That's 1 times x plus pi over 3. 3 times y minus 9. Yes? Question? Did I get a Mr. Kulik from the peanut gallery there? Oh, okay. So everybody, so far so good. Right, so the general form is trig function. So if I plug a positive pi over 3 in there, I have x minus pi over 3, right? If I plugged a negative pi over 4 in there, I'd have x minus a negative or plus pi over 4. Does that feel okay? It's because the general formula has a minus sign here. That's why you're getting opposites, whereas we have just a regular plus sign there, so you're not getting the same action with the k's. Okay with that, Sophia? Cool. It is cool. Let's see. Now we have to go to our key point sheet. So I go to my key point sheet and look at my cosecants. And these are all the key points that I'm going to need. I have to use all of them. I know it's a ton, but it'll be okay. All right, so let's get going then. I'm going to just start kind of copying them down. I think it was 1, or is it -1 here? Oh, it's 2. Good thing I checked. Oh, yes, of course it is. That is 10 pi? No, 11 pi over 6, 2, and then 2 pi over 5. Let me just scroll back up and check to make sure that I did copy those correctly. I think I did. Oh, goody. I'll scroll back down to the bottom for those of you that were still copying. So nothing much different about this one, right? Same kind of thing, it's just exhausting amount of them. Ugh. It's going to take forever, Mr. Kulik. I know. Can't help it. It just is what it is. So, let's just get back to plugging in. And as Julia pointed out, for these ones with the undefineds in them, there's no sense in rewriting the y-coordinate as anything other than undefined, because no matter what we do to it, we still get undefined, as we talked about earlier, right? Yeah. So pi over 6 plus pi over 3 is pi over 8? I hope not. 3 pi over 6, or just pi over 2. And then 6 minus 9 is -3. I shortcutted through some steps there, but it was just arithmetic. Everybody okay with me shortcutting the arithmetic there? Okay. So Don't forget how to add fractions. I can't tell you the majority of the times when I grade things like this, the mistakes students make are arithmetic, like not knowing how to add fractions. And I say, ay caramba, you did this every year for like the past 6 years and you still can't do this. And then I cry a little. It's sad. Okay. And what is pi over 2 plus pi over 3? 5 pi over 6? Is that what you said? Okay. And the next one, just going down the line. Oops. And what is 5 pi over 6 plus pi over 3? 7 pi over 6. I think that's right. And then, woo, thankfully we get an easy one. At least the y-coordinate's easy. What's pi plus pi over 3? 4 pi over 3. Yeah. Okay, scroll me down some more. And keep on at it. Grinding this away. And you got to be thinking to yourself, Mr. Kulik, this stinks. And I would say, student, you're not incorrect there. It's not a lot of fun. But it's really kind of the best way. It just kind of, yeah, just a little labor intensive. But it's easy labor, but it's labor intensive, right? 7 pi over 6 plus pi over 3 is? Yeah. That's good. So just grind, grind, grind all day long. Here I go. Pi over 2 plus pi over 3 is? $11 pi over 6, I think. Do you guys agree with that? This is 2 pi over 6 plus 9 pi over 6. Gives me 11 pi over 6's, right? If you think I made a mistake, please holler at me. Okay. 11 pi over 6 plus pi over 3 is? Yeah, 13 pi over 6. And then my last one. Oh, thank you for finishing. This is exhausting. 2 pi plus 3 pi over, or I'm sorry, 2 pi plus pi over 3 is 7 pi over 3, right? Yeah. Okay, goodness gracious. This is pretty rough, but it's doable. First thing I'm going to do is just think about what unit I want to make my x-axis go up by. Hopefully it seems pretty obvious to you. You want to go up by sixths of pi. So this is like 2 pi over 6. This one is like 3 pi over 6. This is 8 pi over 6. And this one is like 14 pi over 6. And then we can start graphing. So let's see, 1, 2, 3, 4, 5. Oops, that was 6 already. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And are we out of time? Yeah.